talking about radio communications. Now you may say, am I going to be talking on the radio? No, you're not. As a remote pilot, you're not going to be talking on the radio, but you can find a lot of really good information by listening to the radio. So my primary goal with this chapter is to give you the skills so that you can listen to the radio and get some information that's going to help you be safer, especially when you fly near other airports. The reading material for this is going to be the PHAK, as always, Pilot Handbook of Aeronautical Knowledge. 1422 and 1423 is where you'll find some information. There's a lot more in another document I'll give you in a second. You can also find information about this in the study guide in chapter 7 and also in the ACS, the Airman Certification Standard, which is going to be in area 5, and task A is related to radio communication. There's also a really good book. If you want to learn more about radio communication, now it's completely optional at this stage, and it's going to be to download this book right here, which is the Radio Communication Phraseology and Techniques book. It's published by the FAA, and it's got a lot of really good information. So I recommend that you take a look at that, just in case you're interested in this kind of stuff. Another good way that you can get better at listening to the radio is by listening to the radio. I hate to say it, but the only way that you'll get it is by practicing. You can go on liveatc.net, and this will give you access to all the frequencies in the country, including some archives where you can listen to past recordings of a lot of different airports, not only in the country but in the world. So go ahead and take a look at that resource. If you want to get your ear used to all this stuff, this is where you're going to do it. Why is it so important that we know about radio communication? Well, it's important primarily for manned aircraft that are operating in the national airspace system. Radio communication is going to be used for helping the flow of traffic between all the controlling agencies and the pilots, and also between the pilots and the pilots, so they can tell each other what they are doing. It's just a way to communicate with each other. Very important right here. You, as a UAS operator, are encouraged to listen to the radio, but you are not allowed to transmit on aviation radio frequency. I see this coming up all the time on forums. I see people asking, hey, what kind of radio should I get to talk to other pilots? You can't. You do not talk to other pilots. This is a violation of the FCC regulation. You have to have an FCC license before you can transmit on any of these frequencies. The way that pilots are doing it inside of their aircraft, when it has a radio installed, comes with a radio license, which gives them the ability to talk on the radio. I'm going to do a quick sideline here and tell you, when I was the manager of a flight school, we had an accident one day, or an incident, where an airplane was coming in and was going to do a landing with the gear up because the gear was stuck. And we had to go to the side of the runway, and I took a radio with me so we could listen to the pilot, but we were not allowed to transmit on that radio. And it was even me as a pilot sitting on the ground. I was not allowed to make radio calls. I had to call the tower if I wanted to transmit anything to that pilot. So that's where you are with this. You are allowed to listen. You are not allowed to talk. There's one caveat to this, one exemption, which is in case of an emergency, if you have a radio, let's say you had your drone that just flew away and is about to take off and go up into a controlled airspace where there's a lot of large aircraft that are flying, then I would use the radio in this case to declare an emergency and say that you have a rogue drone that's just flying into somebody's airspace, and just to let them know what's going on. Language. It's almost like a different language. It's all very organized, but it's also very fast. It's also pretty poor quality in general. And if you don't know the language, then you're going to have a hard time comprehending what they're actually saying. There's very specific phraseology and very specific procedures, and I'm going to give you some tips in here. Like I said before, the best way to learn is to actually listen to the live feed. Another thing that you can do, and I actually recommend that you do, is you learn the phonetic alphabet. And this is the alphabet right here. This alphabet right here is standard across the world. When I flew in France when I was younger, we also used the same exact alphabet. So Alpha, Bravo, Charlie, Delta, Echo, Foxtrot, Golf, Hotel, India, Juliet, Kilo, Lima, Mike, November, Oscar, Papa, Quebec, Romeo, Sierra, Tango, Uniform, Victor, Whiskey, X-Ray, Yankee, Zulu. And then the numbers also have a standard. 1, 2, 3 is actually tree. Tree is a lot easier to say by everyone. The TH sound is something that's very English, that's very difficult for non-natives to pronounce. So tree is the actual number. 4, 5 is an F, easier. I'm not actually quite sure why 5 is 5, but then 6, 7, 8, 9 is niner, and then 0 is 0. Okay, so the different ones is going to be tree, 5, and niner. Quite frankly, I say 5 because it really doesn't sound all that different, and I say 3 as well. I think most people do. Niner, I do say niner because it is part of. It's just different enough that that I would say it. When we talk about figures, any figures that we're going to tell on the radio, we're going to spell them out. Hundreds of feet, thousands of feet are going to be spelled out. 300 is going to be 300, and that might make sense. 4,500 as opposed to 4,500. 4,500 is not acceptable. 4,500. 10,000 instead of 10,000. 10,500. So 10 doesn't exist, 11 doesn't exist, 12 doesn't exist. It's 1, 2, or 1, 0. Remember when I gave you the runways? I said runway 09 or runway 27, not runway 27. All these numbers are going to be pronounced for each of the digit. Like I said, 18 is going to be 18. If we're talking about a frequency, the decimal is going to be 122.1. 122.1. In terms of altitude, pronouncing altitudes, if we're below 18,000 feet, then it's going to be spelling out everything. 13,800 instead of 13, whatever you would say that, 13,800, 13,800. If it's above 18,000 feet, then we're going to start using what we call flight levels. Flight levels are basically the altitude, and you take the last 2 zeros out of the picture. So 20,000 feet is going to be flight level 200. Flight level 200. If we're talking about the direction, remember heading of north 360, and we're going to spell it out 360. A heading of east is 090, 090 actually I should say. And then speeds are also going to be spelled out. 320, 320 knots is 320 knots. May hear the controller say traffic at X o'clock, 2 o'clock, 1 o'clock, 12 o'clock. It's all in reference to the to regular watch, okay? If we have here 1, 2, 3, 3 being east, and then 9 being west, and then south being 6, and then north being 12, then that's what we're going to be using. So if the controller says traffic at 12 o'clock, it means that there's something ahead of you, right in front of you. Then if it says traffic at 2 o'clock, then it's going to be traffic to the right a little bit. And then traffic at 9 o'clock, and then traffic at 6 o'clock. Okay? So just in reference to the hour on the clock. Another standardized procedure for radio communication is going to be call signs. And these call signs are a number that is assigned to each of the airplane. It's called a tail number. Now you have an FAA registration that you put on your drone. It's a pretty long number, but for aircraft, it's just going to be a shorter number. Just think about it as like your license plate. And that tail number is what you're going to use to identify yourself. You don't call the radio and you say, hey, this is Greg, and I'm taking off from Prescott in my Cessna. You're going to say, this is November 123 Foxtrot Tango, and that's your tail number, and you're going to tell them, and they know exactly who you are. So from here on out, they're going to be telling you 123 Foxtrot Tango and calling your name. So on the initial contact, you're going to give them your full tail number. For example, November 123 Alpha Bravo. Then after that, the tail number might be shortened by the controller. So they may actually say 3 Alpha Bravo instead of saying 123 Alpha Bravo. The reason I'm saying all this is when you listen on the radio, you can hear these full tail numbers at first, and then they're going to come back and shorten that tail number. So when you're listening to someone and you hear 3 Alpha Bravo is in the left downwind for runway 15, then you can look up and say, hey, I know I'm pretty close to runway 15, and I hear an airplane right here. Oh, this is the airplane. It's right here, and it's flying in the downwind. So I know it's at 1,000 feet. That's how you use that information. Here's an example of a tail number. This would be Cessna November 342 Sierra Alpha. Here's another example here, larger airplane. This is a citation, Cessna citation. So there would be citation 570 Lima Tango. And then when you get to the really large airplane like United would be United and then the flight number after this. It doesn't match the tail number, but it would be United Flight 146, for example. And uncontrolled airports, or I should say, I want to tell you a little bit more about radio communication when you get to controlled airports and uncontrolled airports, or I should say towered airport and non-towered airport. For airports that do not have a control tower, then the position reports are going to be up to the pilot. They should be making radio calls, but they don't have to. So what I'm saying here is it's not required. So if you're flying your drone around one of these airports, you have to make sure that you don't rely entirely on the fact that somebody has to make a phone call, because they don't have to, or a radio call. They don't have to make a radio call. So if you don't hear someone, but you see someone, well, they're not making a radio call, which is not safe, by the way. I don't like going to those airports and people going in and not making a radio call. It's extremely dangerous for manned pilots, and it could be dangerous for you as well. But just be aware of that fact. Now, when these calls are being made, there's 3 different frequencies that can be used, 3 different ways, I should say, that they can communicate on. The first one is via a Unicom operator. I'm going to talk about this in a second. A Unicom operator is a guy on the weekend that's sitting at the airport and that's acting as an air traffic controller, if you want, even though they don't have any power to basically tell you what to do. They're just here to give you information. Okay, that's the Unicom frequency. Then you have what's called a self-announced broadcast, which is the CTAF frequency. That's another way where you can make your radio calls. I'll show you how that works again in a minute. And then there's this last thing, which is very uncommon, but I have to talk about it, which is the flight service station. Now, the flight service station used to be this thing that was pretty big and provided a lot of services, but in the last few years, I would say last 5 years, the flight service stations have been closing left and right. The primary reason is because a lot of that information is available online now. And in the past, when I was a student at first, we always call a flight service station because that's how you get information. That's how you file flight plans. That's how you get weather information. That's how you get a lot of stuff. Now, all this stuff is available online, so there's not as much of a need for the flight service station. But if there is a flight service station on the field, then you can use it for that. That's all I'm going to really talk about for that. I want to concentrate on Unicom and on the CTAF so you get a better idea of what those are. Integrated community. Now, the Unicom frequency stands for Universal Integrated Community. Now, the Unicom frequency is where you're going to get public airport information about the public use airport, and that's going to be if the pilot requests it. What you do is, if you're a pilot and you get to that airport, you're going to talk on the radio and say, is there any airport information? And then somebody else is going to come back and say, yeah, we are using runway such and such today. The wind has been reported as from the 320 at 12 knots, and there's 5 other people in the traffic pattern at the moment, or we have an air show going on right now. I mean, any kind of information available is going to be on the Unicom. You can also request weather information, wind information if you want to, if somebody, again, is responding on the other side. So these are going to be available when there is no tower or when there is no flight service station available. Another frequency, which is usually associated with the CTAF frequencies, with the Unicom frequency, is called a CTAF. And the CTAF stands for Common Traffic Advisory Frequency. And that CTAF frequency is where people are going to be making their position reports. That's the one I was talking about that's optional. That's where pilots are going to go and say, I'm in the left downwind right now for this airport, and I'm about to turn on final, and I'm about to land on the runway. I'm about to taxi to that runway to take off. Anyway, to let other people know what you're doing at untowered airport. Now these reports, these common traffic advisory reports, they can be made on the Unicom frequency, where you're going to get also airport information, or it can be made on the tower frequency. So for example, the airport that I fly at is Prescott, which is a towered airport, but at night it's not towered anymore. The tower people go home, so all of a sudden it turns into an untowered airport. So in this case, these CTAF reports are going to be made on the tower frequency. Okay, I hope that makes sense. So it can be either the Unicom frequency or tower frequency. I'll show you where you find these frequencies, by the way, in a minute. There are a few airports across the country that do not have a CTAF frequency or a Unicom frequency. And in this case, what we're going to do is, if you want to listen for the traffic, you're going to go to what's called a multi-com frequency. It's just basically a shared frequency across the country, and that number is 122.9. So in case you come up with an airport that doesn't have that frequency on the chart or anywhere you can find, then 122.9 is what you want to listen to. The CTAF frequency. And here's what you're going to say. You're going to say something like, Sedona. Here's an example of traffic advisories that we can find. First off, 10 miles out, that's when you're going to call the CTAF frequency. And here's what you're going to say. You're going to say something like, Sedona traffic, Cessna 123 Bravo Foxtrot, 10 miles south, inbound for landing, Sedona traffic. Now you notice I said Sedona traffic twice. The reason I'm saying it twice is because most of the time these frequencies, these CTAF frequencies or Unicom frequencies, these are shared frequencies between different airports. So Sedona is located a few hours, like about an hour north of where I am in Prescott, and there could be another airport 50 miles away, 60 miles away that's using the same frequency, and that's going to be called something else. So in that case, when people are listening for that frequency, they could be picking up frequencies from two different airports at the same time. So you want to know which airport it relates to. Okay, it's a shared frequency, it's a shared line. Then the next thing is, as we get closer to the airport, here's what these radio frequencies are going to look like. Now, here we are entering the pattern. So the airplane is located right here at the north of the pattern, doing the entry leg midfield downwind. So it's going to say Sedona traffic, Cessna 123 Bravo Foxtrot, entering the pattern, midfield left downwind for runway 9er, Sedona traffic. So here, let's listen to what it says. Entering the pattern, midfield left downwind. So I know that they are on the left downwind to runway 9er. So I know exactly where they are now. They're north of the airport. If I listen to this, entering left midfield downwind for runway 9er, then I know exactly where they are. And then Sedona traffic right at the end. So if you listen to this on the radio, it would sound like Sedona traffic, Cessna 123 Bravo Foxtrot, entering the pattern, midfield left downwind for runway 9er, Sedona traffic. That's how fast people would read it, which can be sometimes even faster. And sometimes if it's mumbled because of the radio quality, it may be hard to listen to. Once you're established into the downwind, you can make another call in downwind, and then you go into base. Now, once you're in base, you're going to say Sedona traffic, Cessna 123 Bravo Foxtrot, left based runway 9er, Sedona traffic. Okay, pretty straightforward here. Again, I know where the airplane is. It's going to be to the northwest of the airport on the base leg going into runway 9. And then when you get to the final, it's going to say Sedona traffic, Cessna 123 Bravo Foxtrot, final, runway 9er, Sedona traffic. That's it. Then you land, and then when you landed, you're basically going to clear the runway, and, well, you're not, the pilot is. Sedona traffic, Cessna 123 Bravo Foxtrot, clear of runway 9er, taxiing to park, Sedona traffic. That's it. Then the airplane is gone. The whole time, you as the remote pilot, you're going to be listening to this, and you'll know exactly what that person is doing. You'll know if they're still 1,000 feet north of the airport or if they're on short final about to land. These are important pieces of information that you need to have. If they're taking off, then this is what it's going to sound like. Sedona traffic, Cessna 123 Bravo Foxtrot, departing runway 9er, Sedona traffic. I've said this before, but I'm going to say it again. Remote pilots need to understand radio communication to help with spatial orientation. It helps with knowing where everybody else is around you. You are not allowed to transmit on any aviation frequency unless it is an emergency, but you should be listening. If you're going to be listening, this is the radio that I use. It's not all that expensive, and this is something that you should have if you're going to be flying quite a bit near airports. This will give you basically a good range, several miles away, and you can listen to all different kinds of radio frequencies using that. Procedures at airports that have a control tower. We've talked about the procedure at untowered airport. Let's go ahead and talk about procedures at airports that have a control tower. This is a lot easier. And the reason it's easier is because there's a controller. So you have to follow the instructions from ATC from the controller. And every time that the pilot gets an information from the controller, they have to repeat that information. It's going to be called readback. So if the controller says, clear for takeoff runway 15, then the pilot is going to say clear for takeoff runway 15. It's called readback. The reason we do it this way is because we want to make sure that the controller knows that we understood what the controller said. The language in itself is going to be very similar to what you hear at untowered airport. Entry, downwind, base, final, all these terms are going to be the same. Except instead of the pilot making self-announcements, what it's going to be is the controller telling them what to do. Enter left downwind for runway 9er, or report base. Sometimes they're going to say report base. So they're telling the pilot to tell them when they're getting to base. Anyway, you can hear all this stuff when you're listening to the radio. Again, practice, practice, practice. Here's an example. The controller can say you're number 2 following the Piper on final. Now you're number 2, now you're sitting in the airplane and you're following the other airplane that's on short final, and you take a look and you say, yep, I've got him in sight, that's who I'm following. I'm going to say, where do I find these frequencies and how do I know who I need to listen to based on where I'm flying? Well, pretty simple. It's actually going to depend on whether it's a towered airport or an untowered airport. Now I'm jumping the gun a little bit here. I'm showing you what's on the charts. The charts, we're going to take a look at them in more detail in the next presentation, but I wanted to show you some information here. Now I'm going to show you the chart, and I'm going to show you the chart supplement, which we've taken a look at already. If you see here, for this airport, you can see this 125.3, the CT stands for control tower, and the 125.3 is the frequency for that airport. And that's what you can listen to during the day in order to listen to the radio. And then in here it actually says there's a little star next to it, and it says part-time operation. That's what the star means. And if you look on the bottom right of that box, there's a 122.95. That's the Unicom frequency. At a control towered airport, the Unicom frequency is going to be where you get some services for that airport. That's what you want to listen to. If you want to get fuel, for example, you're going to call on a Unicom frequency and then they'll bring you fuel. Now, if you look in the chart supplement, we find the same information. We can see that the CTAF, the tower frequency, that yellow line, the second line, it says Prescott Tower 125.3 in operation between 1300 Zulu and 0500 Zulu. And then it says that the CTAF frequency is actually the same as the tower frequency. So that's where we're going to make our position reports. And then the Unicom frequency is 122.95. When the tower is closed, we're going to be making all of our calls on 125.3. That's where you need to listen to as a remote pilot in order to listen to the traffic at night. If you're flying at a non-towered airport, slightly different story here. We have several numbers in here. You can see that it says 122.7 with a C. The C is the CTAF, that's what it means. So 122.7 is the CTAF frequency. If you look in the chart supplement, you'll see that the CTAF frequency and the Unicom frequency are the same. So 122.7 is where you're going to find your information. Chapter. So, first chapter. Let's go ahead and talk about some typical FAA questions, and then we'll go ahead and move on to the quiz as always, and then move on to the next chapter. So, first question, the correct method for stating, I'm going to say it incorrectly, 4,500 feet MSL to ATC is 4,500. 4,500. The correct method for stating this, 10500, is going to be 10,500. 10,500. An ATC radar facility issues the following advisory to a pilot that's flying on a heading of 360. Now, if you're flying on a heading of 360, you're flying north. You're flying towards the north. Traffic 10 o'clock, 2 miles, southbound. Southbound means the traffic is coming south, so it's heading straight towards you. 10 o'clock, 2 miles. 10 o'clock is a little bit to our left, so it's going to be to the northwest. That's where it's going to be located. Looking at this figure right here, Coeur d'Alene, we have which frequency should be used as the CTAF, Common Traffic Advisory frequency, to monitor airport traffic. So if we look at this diagram right here, if you look at the figure, you will see, if we zoom in, there's a whole bunch of frequencies, and then there's a C circled, and the 122.8, that's our CTAF frequency right here. Don't confuse that with the AWOS that's on top. We'll talk about the AWOS when we talk about charts in a minute. So 122.8. Another one, while monitoring the Cooperstown CTAF, you hear an airplane announce that they are midfield left downwind to runway 13. Midfield left downwind to runway 13. Where would the aircraft be relative to the runway? Now, I want you to pause right here, and I want you to look at that airport right here, which is Cooperstown. That's the airport. And I want you to draw the pattern on a piece of paper and find which one is runway 13, and then find where the pattern is going to be located. Go back to the question, midfield left downwind. Okay, then you unpause and you come back. So now that you figured it out, let's take a look at this. This is the airport. I'm going to zoom in a little bit, and I'm going to take a look at these runways. We have runway 13 right here, which is oriented. If I'm sitting on that 13, I'm basically pointing towards the southeast. So that's 13. And then here, the opposite would be runway 31. Okay, 180-degree difference. Now, if I'm on the left pattern for runway 13, this is what it's going to look like. And you see the arrows making all left turns. And if I'm entering on the midfield left downwind, then this is where the airplane is going to be located, which is the answer is going to be either northeast or east of the airport. Let's take a look at the answers. We have A, answer is east. Okay, the aircraft is east. So that's the answer right here. Figure 25. If Dallas Executive Tower is not in operation, which frequency should be used as Common Traffic Advisory frequency to monitor airport traffic? Let's take a look. This is a controlled airport, and now it's saying which is the CTAF frequency if we don't have tower. This is the same example I showed you in Prescott. That's that number right here, and then it's got a C after it for CTAF, 127.25. All right, chapter 4. airspace. Airspace is one of these chapters. It's actually probably the most important chapter in this course, along with the next one, which is the charts. The problem with airspace is that it's extremely complicated. And it's extremely complicated because if we think about airspace, it wasn't designed for unmanned aircraft. It was designed for manned pilots, and there's different levels of complexity. So I'm going to walk you through this, but what I'm going to give you is I'm going to give you some background as to when we start talking about each of these airspace, as to why it is the way that it is, and then kind of how you are going to operate in that airspace, which is, in the end, the bottom line, when you start flying for real, it is actually a lot easier than what the FAA makes it look like in the actual exam. If I personally were to redesign the entire exam for Part 107, I wouldn't even include any of the charts. I would talk about airspace, but I would make it quite a bit simpler, and then I would actually not even talk about the charts. I would show you the charts that UAS pilots are actually using. Now, I'm not in charge, so I'm going to teach you the things that you need to know in order to not only pass the test, but have a much better understanding of the entire ecosystem. And I think it's important because you're going to be sharing the airspace with other people. And as we get more and more complex operations out there, you're going to be sharing the airspace with even more complex type of other aircraft out there. So I want you to have this grasp. I want you to have this understanding. Now, fair warning, this is going to take you a little bit of time to get used to. And I want you to go through these videos as many times as you need. As a matter of fact, I think most people are going to go through the videos once, kind of try to ingest as much information as possible, and then do a second pass. And I think on the second pass, you're going to be getting a lot more of the nuances. As you go through each of these airspace, I know you're going to have questions. Chances are your question is going to be answered a little bit further into the video. So just hold off on the questions for now until you go through each type of airspace, at least when we start talking about controlled airspace in a minute. Because I've seen people say, well, what about this class? Well, I'm like, well, this class of airspace we're going to talk about in a minute. So just hold off, and then I'll answer that question then. So don't get frustrated. This is something that I've been teaching for pretty much the last 20 years, and I see people struggle with this all the time, whether it's at the airplane level when I teach private pilots, even when I teach commercial pilots, quite frankly, that have had already some experience flying before, and we get to the airspace and there's still some confusion, and so don't feel too bad about that part. But I'll simplify it as much as I can. And what I'm going to do too is I'm going to give you some tips of things that you actually need to know for the real world that is actually not in the test. I'm going to show you how you can actually find if you need airspace authorization, and I'm going to show you the tools on how to do this. And at the very end of this course, I have videos that explain when you're on the field how to actually do it. But I'll give you the concepts if you want in this video, and then if you want more information about this, go to the very end of the course. There's a bonus section there, and in the bonus section I talk about how to actually do this. So all right, enough talking, let's get kind of started with this, and let's take a look at our references right here. In terms of the reading material, we have the Pilot Handbook of Aeronautical Knowledge in chapter 15, talks about airspace, and we have 808222, the Remote Pilot Study Guide. In chapter 2, you'll find information about this as well. And then if we look in the ACS, the Airman Certification Standard, there's a whole section here, task 2, that's specifically about airspace. The next thing is an overview of what we're going to talk about in here. First off, I'm going to give you some general information and then kind of explain the different types of airspace. There's actually quite a few of them. We're going to define a few terms so that you can understand what I talk about in the future. And then we're going to go straight into controlled airspace, class A, B, C, D, E, and G. And then we'll talk about special use airspace. Special use airspace is the prohibited, the restricted areas. We'll talk about warning areas, military operating areas, control firing areas. And I'll give you a quick cheat sheet at the end of each of these. So at the end of the control airspace section, I'm going to give you a cheat sheet that kind of encompasses everything. And then at the end of the special use airspace, I'm also going to give you a cheat sheet. And then we'll talk about other airspace. That's temporary flight restrictions, parachute jumping areas. We'll talk about military routes and then a special type of military activity. We'll talk about VFR routes. We'll talk about some more obscure ones, and then the LA, the TURSA, the NSA, the FRZ area. We'll talk about the Air Defense Identification Zone, because that's not something that you really want to mess with. This is the border around the country, and it's something that you don't really want to cross. So you need to know where it is, especially if you live in states that are bordering other countries. We'll talk about special flight rules, and then we'll talk about national parks and wilderness areas, because you need to stay away from these, and I'll show you how you can identify them. And then I'm going to give you a few tips on how to do typical FAA questions. So let's get started. Out of trouble, and why you need to understand airspace. Well, I think it's pretty obvious. You want to stay out of trouble with your UAS, and you want to prevent any kind of encounters with manned aircraft. And if you start to understand airspace, you'll understand where manned aircraft are going to be flying at lower altitude, at very fast speed, or where there is activity that you shouldn't be part of. When we talk about restricted areas and prohibited areas, these are areas that you definitely want to avoid. And so I'll be going into the details, but this is basically why you need to understand all of this. Airspace is going to be defined. Remember, we talked about regulation, we talked about Part 107. Airspace is defined in Part 71 and Part 73 of the Code of Federal Regulation under Title 14. So instead of Part 107, if you want more information about this, that's a good place. Well, I don't know if it's a good place to find it. It's the place where it's defined. It's kind of a lot of text, so it's hard to actually read. But if you ever needed it, that's where the information is located. And the primary purpose of all of this, by the way, is we have an air traffic control system, and that air traffic control system is designed, it's controlled by humans, it's controlled by an air traffic controller, and it's designed to prevent a collision between aircraft that are operating in the system. There are some parts of the country where there is no one that is controlling the airspace. We'll talk about that. That's Class Gulf airspace, which is actually kind of a big part of the country. And then a lot of times you're going to be operating in Class Gulf. So nobody's in charge of that airspace, and you can pretty much do whatever you want. When you start flying closer to airports, or closer to city centers, I should say, where you have more population, typically we'll find different types of airspace. So I'm going to show you how to identify these. And by the way, in this presentation, this is airspace only. I am going to show you some of the charts, and I am going to show you how the airspace is depicted on the charts, because I think it's a lot easier to do it that way. And when we get to the chart section, then I'm going to go into more details about this. But so you'll see charts is way more than airspace. Charts gives you information about obstacles. It gives you information about latitude and longitude. It gives you information about roads, creeks, wires, all of these things that are in here, and also airspace. That's why this is two different chapters, airspace and charts. But really, if you think about it, they should really all be together. But because this chapter is long enough as it is, I decided to break it into two. So I've been doing this a long time. Some people sometimes ask me, why don't you talk about charts first and then talk about airspace? I think that's backward. If I showed you the chart and I say, oh, this is class A, B, and C, and D, it'd be like, what is class A, B, C, and D? So I define the classes first, I show you what they look like on the chart, and then I go into more detail to show you exactly what that airspace looks like, and then what else is actually on the chart. So there's a method behind the madness, I like to say. Types of airspace, and you've already seen this in the introduction, but the first one I want to talk about is controlled airspace. And let's talk about what actually controlled airspace means. And if you think about the word controlled, it means that somebody is in control of the airspace. Somebody is in charge of the airspace, and that's going to be air traffic control. And air traffic control is going to provide what we call a service. A service when and again, like I've said before, this is all designed for manned aircraft in the first place, okay? The last 100 and some years, we've been designing aviation around manned aircraft. So we have the ability to provide a service to manned aircraft that are flying in certain areas of the country, and that's controlled airspace. So a service means traffic separation, for example. If I'm flying in my airplane and I want to know if there's other people around me and I want air traffic control to help me get that separation with somebody else, that's going to be a service, and that's only available in controlled airspace. Now you're going to say, why do you even mention this? We're not flying a manned aircraft. I understand that. The reason I mention this is because you need to understand that when you are in controlled airspace, it means that there is a chance, a high chance, that there's other people flying in there that are not UAS, aka manned aircraft. So we need to keep that in mind. Controlled airspace is going to mean typically more busy airspace and a place where we need to keep our eyes open because that's our chance to encounter or lack of chance to encounter somebody else in the airspace. And controlled airspace is defined as 5 different airspace: A, B, C, D, or E. And I'm going to go over each of these and kind of explain. You can actually take Class A out of the picture. It's way high up there. I'll mention it in a second, but it really comes down to B, C, D, or E. So I'll talk about these and then define them. And then there's another airspace out there that's going to be Class Gulf, which is the last one. And in order to enter in Class A, B, C, D, or E, I put this last bullet in here. It says clearance is required to fly a UAS in those airspace. And I'll talk more about this and I put a little asterisk right here at the end of that sentence, and it's because it's not necessarily true for Class E. Class E is a little bit more complex, but chances are if you're flying in B, C, D, or E, you're going to need to get approval in order to fly in there. And I'll tell you how you can actually do this. So more detail coming up on these in a second. I wanted to kind of introduce these first, and then we'll talk about them in more detail. So we have controlled airspace, and then we have uncontrolled airspace. Uncontrolled airspace means there's no service provided. If I wanted to get traffic separation as I'm flying my aircraft in that airspace, I won't be able to get that. There's no service provided. This also means for you as a UAS pilot that you actually don't need to get clearance in order to fly in that airspace. It's a free-for-all, okay? Everybody's going to be sharing the airspace. Everybody's going to be looking at other aircraft and then just kind of making their own decisions. And that's just the way it is, really. This is going to be labeled as Class G, Class Gulf airspace. So if you hear Class Gulf airspace, it means that you can fly, no need for approval. And then I'm going to show you how you identify Class Gulf on the charts, and then using the other method, using the UAS facility map. The third category of airspace is called special use airspace. And as you can imagine, special use airspace, there's going to be some kind of special activity going on in that airspace, and more than likely we're going to want to either stay away from it or we're going to want to be careful if we fly in that area. Some of these areas you're not allowed to fly, I'll tell you which one, and some of these areas you're going to be allowed to fly, but you're going to have to keep your eyes open. Typically these are going to be set for government purposes. We have prohibited, restricted, warning, military operating area, that's the MOA, alert area, and controlled firing area. So I'll talk about these individually in a second and then kind of explain what each of them is. And yes, you do need to know about these because if you encounter one of these and you try to fly in there, then you're going to be in trouble. You're going to be in trouble either as a Part 107 pilot or as a Part 107 pilot flying for public safety, and this is not something that we want you to do. And then the fourth category, the last one, is other airspace. There is no real way to classify that one. It's just every other airspace that's out there. We have temporary flight restriction. That's going to be an important one we're going to spend time on. We're going to talk about military training routes. We're going to talk about airport advisories, parachute jumping areas, VFR routes. Then we're going to talk about NSA, National Security Areas. We'll talk about the Special Flight Rule Area, it's called SFRA, and then I'll talk about wilderness areas and talk about national parks because you can't fly in there, and I want to show you how you actually get the information about that. Key terms, and I So before I go into all the details, let's talk about a few key terms. And I don't want you to go to the next presentation, to the next video, until you understand these terms, okay? And I mean it because you're going to get confused with the way that I use these terms if you don't understand what they mean. So this is where you have to put yourself in, well, let's get going, and then I think you'll get a better idea. But altitudes out there are going to be using a different type of reference depending on, well, it's kind of arbitrary, unfortunately, but for every altitude that we talk about, there's going to be at least two possibilities. It's going to be either AGL, above ground level, or it's going to be MSL, mean sea level. Mean sea level is kind of imagine above sea level, okay? We could have called it ASL instead of calling it MSL. Mean sea level means the average level of the sea. Believe it or not, the sea level is different depending on which part of the world you're in. So they're using an average sea level. That's what that mean comes from. That's what that information means. But MSL and AGL, okay? Now, right now, I'm right here. I'm in Prescott, Arizona, and my house is located at 5,500 feet MSL, mean sea level. That's the altitude at which I live. When I lived in Florida, my house was around 33 feet above sea level, almost at sea level. So very big difference, but everything is reference to sea level. If I go to the beach and I'm standing right here on the beach, I'm probably 1 foot above sea level. If I put my foot in the water or right at the edge of the water, then I'm at sea level, 0 feet of sea level. Okay, so that's what it means. Now, above ground level is different. Now, above ground level right now, I'm at 0 because my feet are touching the ground. If I jump up in the air 3 feet, probably can't jump 3 feet, but if I jump up in the air 3 feet, right, then I would be 3 feet above ground level. Ground level is just, if you have a mountain, that's the ground level. When you fly your drone, you're going to fly your drone 400 feet above ground level. We've talked about this before. So you follow the contour of the terrain. Whatever your MSL altitude is, doesn't really matter in our case, but I'm going to use MSL a lot because the charts are using MSL a lot. And the reason is because manned aircraft pilots are using MSL altitude for their altimeter. When I fly my airplane, I have an altimeter and it's always set to MSL. So if I'm sitting at the airport in Prescott, the airport is at 5,045 feet. When I look at my altimeter on the runway, I'm at 5,045 feet. I'm not at 0. We don't use that reference of AGL. So I'm 0 feet AGL, but I'm technically at 5,045 feet MSL. So I'm going to use these terms. And sometimes, well, you'll see on the exam, sometimes they're going to ask you a question in AGL, and sometimes they're going to ask you a question in MSL. So you have to be able to visualize the top of an obstacle, the top of a tower that you're inspecting maybe. The top of that tower is going to be at X number of feet MSL and also X number of feet AGL. That AGL number is always going to be smaller than the MSL number. So I'll show you a bunch of examples, and then I'll try to make sure that you understand when I say AGL and when I say MSL, the difference between the two. This is one of the biggest area of confusion for students. So I'm going to, again, make sure that you understand these two terms. And at one point, you're going to have to do a little bit of math in your head and really figure it out. What works for me is I picture this from a side profile, and I look at it and I say, here's sea level, here's where the land is located, and then here's where my object or my drone or my airplane or whatever is located on top of it. And if we're referencing to the sea level, which is all the way down here, then that number is going to be pretty big. Or if we're referencing to AGL, above ground level, then that number is going to be much smaller. It's going to be above the surface of the Earth. So we'll get back to this. I'm going to show you a bunch of examples. Another way that we can measure altitude, which is not really appropriate for unmanned aircraft, for UAS, is using flight levels. Flight levels is something that we start utilizing above 18,000 feet, and not really something that applies, but some of this airspace is defined with flight levels, so that's why I mentioned it in here. You won't really see flight levels on charts, you won't see flight levels on the exam, but I want you to kind of understand what flight level actually means. But flight levels is going to be the altitude, so 18,000 feet, that would be flight level 180. We take away the last two numbers. So if you see a flight level, if you're flying a commercial on the commercial jet, you're going to be flying at flight level 400, 40,000 feet, or flight level 350, that's 35,000 feet. So just an example of things that you'll see. But here's an airplane. I'll show you a drone in a second. We have an airplane flying right here at 1,000 feet MSL, okay? That would be just flying fairly low, close to the ocean, okay? And we have mountains on the other side, and these mountains are at 500 feet MSL. The top of the mountain is 500 feet above sea level, okay? Then the airplane in itself would technically be located 500 feet above that mountain. And I'm using a peak right here. It would be 500 feet above the peak of that mountain. As you can imagine, as you're flying your aircraft, the AGL altitude changes all the time. It depends on the terrain. If you're flying over a lake, then the altitude, and you're remaining at the same altitude, then the AGL altitude doesn't change. It's going to stay the same. But as soon as you start flying over the terrain, it's always going to change. That's why it's difficult to use AGL as any kind of reference, because it would be changing every minute that we fly. Especially around the area where I live, we have a ton of hills, we have a ton of mountains everywhere. If I flew my drone and I used AGL, then if I had the ability to actually measure that distance with my drone, it would be fluctuating a lot. Now you're going to say, aren't we supposed to be using AGL for UAS? Yes, you are. But guess what you are actually using, which is another unit right here, which is the height above where you took off from. That's what your drone is indicating. I take off from, in my studio right here. If I take off from my studio, that's going to be my 0, and then everything else is going to be measured. When my drone starts flying, it's going to be measuring that height above where I took off from, not really our AGL. And that's what gets people confused sometimes. But most people use that height as the AGL height. But as you've seen before, I've mentioned this in the regulation, that can actually get you in trouble. I don't want to get you too confused right now, because we're not going to worry about this for the airspace, but just know the difference between AGL and MSL is important at this stage, because because we're going to be seeing this in the questions. Here's another example here. We have this tower, and this tower, the base of the tower, okay, the ground, is 2,300 feet MSL, 2,300 feet above sea level. If that tower is 600 feet tall, it's 600 foot AGL above ground, then the top of that tower sits at 600 feet above ground level. Now, can you guess for a second, before I give you the answer, what is going to be the MSL altitude for the top of that tower? What's going to be the MSL altitude for the top of that tower? So it should be 2,300 plus another 600 on top of it. The top of that tower sits at 2,900 feet MSL. Okay, I'm going to let that sink in for a second. That's the difference between AGL and MSL in this case. Now, if we took the example that I gave you before, if we were at sea level, let's say that this tower is around the airport I used to fly at, which was at 33 feet MSL, 33 feet above sea level, then in this case, what would happen is that tower would be at 633 feet MSL. The top of it would be 600 plus 33 feet, so 633 feet. So almost the same number, because we're really close to sea level. But because this is much higher than sea level, then there's a big difference between the two numbers. Let's define a few more terms. And these terms, you'll hear them when I mention a couple things, and I wanted to define them here. A lot of these terms were, well, actually all of these terms were defined for manned aircraft, but there are terms that we still use in the unmanned aircraft world, so you need to understand them. VFR, visual flight rules. When pilots fly, they can use two different types of rules. They can follow two different types of rules, what we call visual flight rules. And in this case, when we follow visual flight rules, you always have to be able to see the ground and have reference to the ground as you fly. That's called VFR. And that's going to be only done when the weather is actually good enough. As we get more equipment on board the airplane, as the pilot is actually qualified to do this, they can fly under instrument flight rules. In this case, that's when they're using reference to the instruments only in order to fly. The instruments in the cockpit, they don't need to be able to see outside. And as you can imagine, that takes some practice. When you fly in a commercial airplane with Delta, with United, with whatever, then that's what the pilots are going to be doing. They're going to be using instrument flight rules so they can fly inside the clouds, fly in the fog, and fly in different conditions. Otherwise, it would be VFR. Now, there's another two terms in here that kind of gets confusing sometimes. We have VMC. These are the conditions outside. These are visual condition. On a good day, on a clear day, you can fly, you will fly in visual conditions, visual meteorological conditions. What that means is that in this case, the pilots can fly either VFR or IFR. They can follow either of these rules to fly in VMC conditions. You, as a remote pilot, are only going to fly in VMC, in visual conditions, okay? Then we have IMC. IMC condition is when it requires instrument. That's when it requires pilots to fly under IFR to follow the instrument flight rules. You as a pilot, as a remote pilot, are not allowed to fly in IMC conditions, or IMC, the C is already conditions, but instrument conditions, okay? I wanted to clarify these terms because we're gonna see them again in a little bit, and then we'll talk about them as well when we talk about weather and weather reports. But you don't want to be flying when other people have to fly using their instruments. That's something that we want to stay away from. Finding all the different terms, let's go ahead and talk about controlled versus uncontrolled airspace and talk about the detail for each of these. Now, I'm going to give you here a picture of kind of the airspace in general around the US and where each airspace kind of belongs, and then I'll go into more detail. The first one is Class A airspace, and Class A airspace is way up there, 18,000 feet to flight level 600. Flight level 600, 60,000 feet. This is where commercial jets fly. This is where much faster airplanes are going to fly. You're not going to be up there, so you don't really have to worry about that one, but that's Class Alpha. Class Bravo airspace is going to look like this shape right here, which is an upside down wedding cake. Now, it's not exactly like an upside down wedding cake. It's got more complexity. It's very dependent on the type of airport that you're at. But the idea is you have a larger volume at the top, and then it kind of tips down to the bottom, and then it touches the surface right on top of the airport. The part that we have to worry about as UAS pilots is not the very top of it. It's that base that touches the surface right here. That's where we need to have authorization to fly. Everything else is going to be way higher than any area that we're going to fly in. Class B is going to be for busy, B for busy for large airports. Miami, Phoenix, Denver, New York, LA, all of these large airports are all going to be Class B airspace. So when you see B, you should be really, really paying attention. Class C is the next level. It's almost like a Class B, almost like an upside down wedding cake, but it's typically just two layers. So one that starts from the surface, and then further away from the airport, one that starts a little higher up. I'll give you some numbers in a minute. C is pretty busy, but not nearly as busy. Daytona Beach has one, Tucson has one, you have some airports near Orlando have one. I'm just giving you the ones that I'm really familiar with. I think Albuquerque is also a Class C, so not nearly as large but as a Class B, but still very busy airports. Then we have Class D. Class D is just a single volume of, and this is a cylinder, by the way. All of these are cylinders. They don't look like it from the profile view, but it is a cylinder with a radius. And the Class D is going to be the same thing. It's going to be a cylinder, but it's a single cylinder. And these are found around other airports that are somewhat busy, but not busy enough to have C or D. So we have Prescott, where I live, is a Class D. If you have something that has a flight school usually, or even some very few commercial flights that are going to that airport, it's probably going to be a Class D. And then we have Class E. Now, Class E is a bit confusing. I'll get back to it in a minute. But Class E, pretty much anywhere in the country, is going to start around 1,200 feet above ground level. So it follows the terrain across the country, and it starts at 1,200 feet. Now, there are some exceptions. Some exceptions where Class E can actually start at 14,500 feet. So that's pretty high, and that's MSL, mean sea level. Now, I know I just mixed AGL and MSL. That's the way it is. That's the definition. So 1,200 feet AGL, 14,500 MSL. It can also start sometime at 700 feet, and then sometimes it can even start at the surface around an airport. So we'll talk about all these. Really, again, what we have to worry about in this case is all the stuff that's pretty low out there. But we have to be able to identify all of this different airspace on the chart. If we, and then the last class is going to be a class Gulf airspace, which is everything in white right here, and everything else that's left is going to be uncontrolled class Gulf airspace. So as you can imagine, we are flying right here in the first 400 feet of airspace, and that first 400 feet of airspace, we have to worry about class B at the surface, class C at the surface, class D at the surface, and then class E at the surface. And then everything else is pretty much class Gulf, where we can fly and just have fun without telling anyone. I want to give you this big picture. Now we're going to go and talk about more detail about each of these, and we're going to start with class A airspace. Feet to flight level 600, so never gonna happen. Don't worry about that part. There's more than likely no UAS operation allowed in there unless you're flying a military drone that's going to be much larger than 55 pounds. So not this course doesn't really apply for that. Okay, easy. Move on to the next one, Class B airspace. B stands for busy. Okay, well, it doesn't really stand for busy, but that's what it should mean in your head. Busy airports. That's going to be set up around the busiest airport in the nation. Busy airport means large aircraft, which means Boeing 747, Airbus A320, large airplane that are carrying a lot of passengers. So not a place where you want to be messing up with a drone. But if we look at the classification here, it's going to be that upside down wedding cake with the big radius. It's going to have different layers with different altitudes, but generally it goes from the surface and then all the way to 10,000 feet MSL. Yes, I did say MSL, mean sea level. And this is kind of confusing because a lot of the other airspace are defined as AGL, except this one is defined as MSL. So write it down, learn it. I'm going to give you a cheat sheet at the end of this chapter, but you have to remember this. So 10,000 feet. And then the lateral dimensions are going to depend on the airport in itself. So the Phoenix Class B, for example, is completely different than the Miami Class B or even the Orlando Class B. And I'll show you some examples. And interestingly, that 10,000 foot right here, MSL, 10,000 feet MSL altitude is not even all across all the different airspace, but typically, generally, it goes to 10,000 feet. But some airports are lower and some airports are higher, so you can't really even generalize this. But let's take a look at an example. Let's say Miami is at sea level, and the top of it is going to be at 10,000 feet. Now we go up the hill a little bit and we go to Denver. Denver, for example, is sitting at 5,000 feet MSL, mean sea level. That's the base of the airport. And that airspace is going to look pretty much the same, and is also going to top at 10,000 feet MSL. Okay, so that's what that 10,000 feet MSL actually means. It means that the top of it, in terms of reference to the sea level, that's where it's going to be, 10,000 feet MSL. Now, don't go verify. Don't go look at Miami. Don't go look at Denver, because in real life, they actually don't top at 10,000 feet. I'm just giving you this as an example to explain where 10,000 feet kind of sits and what it looks like. But in real life, these are actually have slightly different tops, but that's not important for this. Okay, Class B airspace. In terms of operating in Class B airspace with your UAS, you're going to be operating in the first 400 feet, right? So you need to have special approval to fly in there. And if you remember, that came from the regulation. The regulation said if you fly in Class B, C, D, or E, then you need to have approval by the FAA. And in this case, there is different methods we can use to do this, and I'll give them to you in a minute when I tell you about the actual real life operation. How do we actually fly in there? Now, Class B is the most restrictive type of controlled airspace. Even manned aircraft pilots actually have to get a clearance in order to enter Class B airspace. It's highly regulated because it's around busy airports. So I can tell you that if you talk to a manned aircraft pilot and you tell them about Class B airspace, they're going to be paying attention. They're going to be extra careful when they get to those areas because it is really busy. This is an example right here of what Class B actually looks like on the chart. That's two different airports, and on the left side you can see we have different circles with the dark blue line. That's going to be the depiction for a Class B airspace. Now, I'm showing you this. I'm not going to go into the detail of each of these right now, but I'm showing you this because I want to show you what a chart is. It's called a sectional chart, and that's going to be on your exam. And I want to show you how somewhat busy this looks. And you can see different circles of different colors. You can see the circles with the kind of the purple, the faded purple, or shaded purple, I should say. It's called magenta. We use the magenta name for that color. And then you have the blue lines, and then you have a whole bunch of text. You have some yellow in there. I'll talk about all these things when we talk about charts, but I wanted to kind of show you first what a Class B looks like. So it's going to be that dark blue line. And on the right side, that's the Phoenix Airport, and you can see it's much more complex, much larger city, and you can see that the shape is not nearly as circular as it was on the left side. So just different shapes, different benefits for the airport. You're gonna say, why is it so complex? And why is it that it kind of goes up like this in different layers? It's to protect airplanes that are coming to land at the airport. And as they come in to land at the airport, we need to reserve that airspace. So the airspace below is not really all that important because nobody really flies there. They're flying in to come down at a slope to land at the airport. That's why these are shaped like an upside down wedding cake, where we need to, the air traffic controller needs to have control of that airspace. That's the primary reason. Here's a close-up of Class Bravo airspace for Phoenix, and I want to show you a couple areas. By the way, this is the airspace right here, so all of the blue lines, and each of these has different numbers. See here, it says 80, and then on top of it there's a bar and it says 90. That's the altitude at which the airspace is actually going to start. It starts, the bottom number is where the airspace starts, and then the top part is where the airspace actually ends. I'm going to show you this in a 3D model in a minute so you have a better understanding, but that segment right here between those blue lines is going to start at 8,000 feet. It's not 80 feet. It's 8,000 feet. We need to add 2 zeros, and it's going to top at 9,000 feet. So the airspace in Phoenix, the Class B airspace, actually tops at 9,000 feet MSL, mean sea level. I know I've said 10,000, but like I said before, not all of them are standard. Phoenix, for example, is a 9,000 foot MSL Class B airspace, not 10. So that's just the way it is right here. If we look at this segment right here, see it says 70 to 90, 7,000 feet to 9,000 feet. Now it starts to drop, okay? It tops at the same altitude, but it's starting to drop as we get closer to the airport. Look at the next one, 6,000 feet to 9,000 feet, another layer that dropped, so we have more control, so not we, so the air traffic controller has more control of the airspace as the aircrafts are starting to come down in altitude to land at the airport. And if we go even closer right here, that center kind of looks like an infinity symbol. I don't know what shape you would call that, but that shape right here starts at the surface and goes all the way to 9,000 feet. That's the center. That's the core, if you want, of that airspace, and that's right on top of the airport. And of course, because it's right on top of the airport where the runway is, then the controller needs to have access from the surface all the way to the top, all the way to 10,000 or to 9,000 feet in this case. I hope this makes sense. That's kind of your introduction to Class B. I'm going to show it to you in a minute in SkyVector. SkyVector is the tool that I use to show you the airspace in itself and to show you the charts. And then I'm going to go in SketchUp, which is the software that we use for 3D modeling, and we model this Class B airspace in 3D so you can actually see. I'm going to rotate around and I'm going to show it to you so you have a better understanding of how all of this stuff is stacked. So let's get to it right now. in the future. So if you don't get all of this just yet, keep going through. There will be a chart section where I talk about all this again in more detail, but I wanted to kind of show you what it looked like on the chart as an introduction, if you want. So this is an introduction, and I'm going to show you a tool here which is called SkyVector. And SkyVector is this great little thing, skyvector.com right here. And from here you can see a whole lot of information, and you can see all of the sectional charts. So I'm actually going to click right here and I'm going to zoom out, and you can see that the entire country shows up right here in charts. Now you will learn later that the charts are divided into different sections. So if you go to the top right in here, you can see we have different things. It says world high, en route, world low, Caribbean. These are all different types of charts. I'm not going to show you these, but we have a world VFR here, and we have the Miami sectional. This is the Miami sectional right here. This is what you would buy as a paper sectional, and here's the whole thing right here. Or you can see it as the world VFR right here, which is the entire world. World, at least the US, available right in here. I will actually show you a different tool that I use to look at the chart, because you can zoom in a little bit more. If I zoom in all the way, this is as far as I can zoom on this area, and I can actually zoom a lot bigger using the charts that the FAA gives you online for free. So with that being said, a couple things about SkyVector that's pretty cool. The one thing that you don't get with just the paper chart or the TIFF file or the PDF file that you download from the FAA is the fact that there's overlays in here. And one of them is the weather information. So here we have a weather station over Miami. Here's another weather station over this airport right here. So it will show you the weather, which is pretty cool. That's the TIFF and the METAR. We're going to talk about this. And then it also shows you TFR, temporary flight restrictions. And we're going to talk about these in a minute in this chapter. These are important because you cannot fly inside of these. So there's an example of one right here. There are layers that you can turn on or off up in here and change them. I usually keep them as default, so this will show up by default up here. This is really all I want to show you on SkyVector. The next thing I want to do is I want to actually go to the actual file from the FAA. And I'm going to start with the Miami sectional. So let me make this larger here. And you can see again, this is the sectional that we had earlier, except now if I zoom in, I can actually zoom in a lot closer in here. Now I'm not going to go that close, but here, this is actually a good example here of how far I want to be into all of this. So if we look in here, you can see the Class B airspace. That's what we want to talk about. And if you remember from the lesson we just looked at, it is going to be this blue, dark blue color right here, depicting all the different levels. Now, it gets confusing with Class B because it is the most complex class of airspace. So I want to start with actually right in the middle right here. This is the center right here. You see the circle? It's right on top of the Miami airport, and it goes right here. And you kind of follow the blue line and see what it does. There's another one right here. It's kind of a weird shape, but see, it goes around the edge right here, and then it comes back, and then it comes back right here. This is from the surface to 7,000 feet MSL. If you remember from the slides, I told you that the definition of the Class B airspace is up to 10,000 feet MSL. Well, it's not always the case. Point in hand right here, we have Miami with a 7,000 foot MSL Class B airspace. Why? I don't know. That's just the way it is. So then we go, and by the way, this circle right here, this is where you will need to have approval from the FAA in order to fly, because you're going to be flying between the surface and 400 feet, okay, and 400 feet. So you're going to be needing to be in here. So this, you will have to get approval to fly here. Now, if we look at this area right here on the side, you see this highlighted right here, goes around, kind of comes back, kind of keeps going around, comes back, goes all the way around this, inside the circle here, and then loops back. This is from 1,500 feet MSL, mean sea level, because it's depicted on the chart, so it's going to be MSL, and I'm going to repeat that a lot, but 1,500 feet MSL to 7,000 feet MSL. if you want to know what the AGL altitude, because we always talk about AGL, right? You can fly 400 feet AGL. That's why people get confused about these charts. We can find what this airport actually is located at, what altitude it's actually at. So this airport is the Miami International Airport, which is the information for it is right here. Now it is busy on this chart because it's a Class B airspace, but I will show you later that you can read the elevation is right here, and that's 9 feet. So this is almost at sea level. What this tells me is because it's almost at sea level, then this 7,000 feet MSL is the same thing as 7,000 feet AGL. So if you're sitting right here and you're flying at 400 feet AGL, you're going to be flying at 409 feet MSL, okay? 7,000 feet tops right here, 1,500 feet at the bottom, which means that if we fly at up to 400 feet, we're going to be flying below this ring right here. We're going to be flying below this entire area here, which means that we don't need approval to fly there. We are not in the Class B airspace between surface and 400 feet. Let's keep going further out. As we go further out, the base of the Class B airspace keeps getting higher. We had 1,500 feet for the base up to 7,000. Here we have 3,000 feet up to 7,000. So as we get further away, then the base gets further away. Again, if you were to fly in this area, you would not need to get approval because you are not in controlled airspace. We have another layer right here at 4,000 to 7,000, and it's going to be this layer right here to right here to right here to right here. This segment starts at 4,000 feet MSL or AGL, in this case only, up to 7,000 feet MSL. All right, let's go and take a look at a slightly different airport here. I want to go to Phoenix, the Phoenix sectional right here. I'm going to show you the Phoenix Class Bravo airspace. It's a little bit different in shape. Now you can see right here in the middle that this is the airport. This is the Phoenix airport. So if we look at this altitude here, the Phoenix airport is located at 1,135 feet MSL. This is 1,100 feet, 1,135 feet above sea level. All right, let's take a look at this Class B airspace here. It goes from the surface to, I'm going to zoom in a little bit, to 9,000 feet MSL. Again, if you remember, we said that Class B usually goes to 10,000 feet MSL. Usually, that's not always the case. This is another example of non-standard here. It goes to 9,000 feet, all right? So, surface to 9,000 feet MSL. 9,000 feet MSL is roughly 8,000 feet above the ground, because the airport itself is located at 1,100 feet. Again, I'm rounding up, 1,100 feet, so the difference would be about 8,000 feet. So this airspace goes all the way to 8,000 feet above the ground. This is kind of important, okay? This has a lot more layers in here. You can see this airport, this layer right here goes from 2,700 to MSL to 9,000 feet. So that would be roughly 1,600 feet AGL to 8,000 feet AGL. Okay, not something that we need to worry about because we would be flying at 400 feet AGL anyway in our case. But this center right here, the one that goes from the surface to 9,000 feet, this one we definitely have to worry about because we're going to need approval to fly in this area. Okay, on the outside here we have another one, 5,000 to 9,000, 6,000 to 9,000. 7,000 to 9,000. The further away we go from the center of the airport, look at this one, 8,000 to 9,000. So you would never really have to worry about this, even though you could take off from this little spot right here and you'd say, hey, there's a Class B airspace. Well, the Class B airspace is well above us, so we don't have to worry about this airspace. We have to worry about the rest of the airspace around it, but we don't have to worry about that specific one, okay? So that's your Class B airspace right here. I'm going to show you this airspace right now in a 3D model so you have a better idea of how the layers actually stack up on top of each other. help students. And this is the sectional for the Phoenix area. And what you'll see what I did is I put different stacks for different airports. Now, the height of the stack is the height of the airport above sea level. So you notice on the northern side here, the big tall blue one right here, that's Flagstaff. Flagstaff is sitting at 7,000 feet elevation. This right here is the airport I'm at, Prescott, 5,000 feet elevation. And as we get down in the valley, if any of you are familiar with Arizona, Phoenix is a lot lower elevation than all the other airports around. So the height of the stack is the height of the airport basically around above sea level. And what I did is I built on top of it different volumes for each of the airspace. Now, what I'm going to show you now is the Class B airspace. So this is the Class B airspace right here. And if you remember all the different shapes, and I apologize because the bottom layer here is kind of low quality because I need this to make it a lot quicker to show you, to have better rendering. But you notice this area here, and you may be able to read this, it starts at 8,000 feet and it tops at 9,000 feet. Now, if we look at this on a 3D view, you notice that that layer starts at 8,000 feet right here and it ends at 9,000 feet. You also notice that all of the Class B airspace is done at 9,000 feet above sea level. And what you see here at the bottom is the Class B airspace starting at the surface. So it's at the surface of the airport, which is located at a few thousand feet above sea level. That's why we have a gap underneath it. It's because there is land, technically, okay? Then we have different layers. Here's another one. I can see somewhat through it right here. It starts at 2,700 and then tops at 9,000 feet. So that's the layer that we see right here. That starts at 2,700 and goes all the way to 9,000 feet. 4,000 to 9,000 right here, this layer right here, 4,000 to 9,000. And the further away we get from this Class B airspace, the more it goes up. And so that's kind of gives you the idea of what a 3D Class B airspace would look like. Again, we have another one right here and then another one right here. These are, it's backwards, but 8,000 feet to 9,000 feet, so 8,000 feet base, and then 7,000 feet base, and then this is a 6,000 foot base right here in the corner, okay? And you notice that there are other airports underneath it, and we're going to take a look at those in a minute. Most of these are actually in Class Bravo airspace. We'll talk about that when we get to it. But I want to show you this, going to give you an idea of the shape of the Class B. So anytime you're going to enter any of these blue airspace, then you're going to need a clearance before you get in. Hence why it's very important that you read this chart. It's a lot easier to see it in 3D than it is to kind of picture this in your head. But when you do, picture it just like it is right here in 3 dimension. We talked about Class B. Let's go ahead and talk about Class C, which is this one right here, if you remember on that little graph. Class C airspace is set up around towered airports that are busy, but not nearly as busy as Class B, but they still have a lot of IFR operation. Remember IFR, I defined that term. It means that a lot of people are using their instruments to fly to those airports, which means that in low visibility, you'll have a lot of people flying there, even if the visibility is pretty bad, which is part of the reason why you can't fly when the visibility is restricted, because chances are there could be somebody flying in the clouds that you don't know about and you can't see them. So the FAA doesn't allow drones to be flying when the visibility is less than 3 statute miles, because that's kind of where IFR is going to start. This is not as complex as Class B, but it only has 2 volumes, and those 2 volumes are going to be an inner volume that's a 5 nautical mile radius, and that 5 nautical mile radius starts at the surface and goes to 4,000 feet AGL. I did use AGL. It's 4,000 feet above the ground. It's a volume that's this tall, okay? And well, it's taller, it's 4,000 feet. And then we have it on top of it, we have an outer cylinder that's 10 nautical mile in radius, and that's going to start at 1,200 feet AGL, and it's going to go to 4,000 feet AGL, same altitude as the inner volume. So that's the upside down wedding cake that you saw. This is what it looks like right here. So the inner volume is 5 nautical miles, and it goes to 4,000 feet. I know it says 1,200 feet right here because that's where the outer radius is going to start, the outer volume. And that one is 10 nautical mile, and then that one goes also to 4,000 feet. So that's kind of what that volume is going to look like. Again, if we wanted to look at it from the difference between sea level and something at higher altitude, Daytona is at sea level, more or less. And so in this case, it would be 4,000 feet AGL, above ground level. If we looked at it from an MSL perspective, because Daytona is at sea level, I know it's not exactly at sea level, but let's assume it is, then it would be 4,000 feet MSL. And then let's look at Tucson, for example. Tucson is sitting around 2,600 feet MSL, the base of the airport. And then in this case, that 4,000 feet would still be AGL, above the ground, but that would take us to 6,600 for the top of that airspace right up here. I hope this makes sense. I wanted to really show you the difference between AGL and MSL right here. If it's not clear, leave a comment down here. But you need to understand these two terms and how they're affecting what's going to be displayed on the chart. And speaking of the chart, I'll show you in a second how that works, but you need to have approval to fly in Class C, just like you did in Class B. If you're flying in that inner volume that starts at the surface, then you need to have approval. Obviously, the outer volume starts at 1,200 feet AGL. We're not going to fly in there because we're flying up to 400 feet AGL, so that doesn't count. So we only have to worry about the inner volume that's on the ground. And also manned aircraft, you need to know this, they have to get authorization in order to enter Class C airspace. So it's not just you as a remote pilot, it's also everybody else needs to enter that airspace, needs to get approval to get in there. Here's an example. This is the Albuquerque right here, Class Charlie airspace. And that's the magenta color, the solid magenta, not the faded magenta that's on the side, the shaded one, that's something different. We'll talk about it in a second. But you see these circles, and what happens, let's do a cross section right here where that pink line is, and we're going to look at it from the south perspective, looking north. Let's take a look at what that airspace looks like here in the cross section. So if we look at sea level, now, the airport in itself, as you've seen before when I told you about how to read airport information, that airport is at an altitude of 5,355 feet MSL, above sea level. So that's dirt, okay? We have dirt for the first 5,355 feet. And then on top of it, we'll have the airport. And then on top of the airport, in the middle, we have a cylinder that goes from the surface, and see it says 94 in that indication right here in the middle, and that 94 is 9,400 feet MSL, because the chart always tells us MSL. Now you remember I told you that that volume is about 4,000 feet above ground level. Well, let's do the math. 9,400 minus 5,355, that actually gives us a volume that's 4,045 feet tall. Close enough to the 4,000 feet that we defined earlier. So it is 4,045 feet above ground level. That's where the top of that airspace is going to be located. Now you're going to say, wow, that's a lot of math. Well, you don't really have to worry about doing the math as to where the top of that airspace is located. All you have to look at is it says surface. And if you're going to be flying inside of that airspace, at the surface, you're going to be in Class C airspace, then you need to have approval. And then I'll show you how to get approval. But that's really what you have to worry about. Now, in terms of the other volumes on the side, on the left side here, we have a volume that actually starts at 69 and goes all the way to 94. That 69 means 6,900 feet MSL, and the 94 means the same thing that it did before, 9,400 feet MSL. But if we do the math, then that would be the difference between 6,900 feet MSL and 5,355. That would be how high that volume is above the ground. And on the right side, we have another one that says 7,800 feet MSL. So this is a bit more complex. It's got different, you see it's got different volumes at different altitude. And again, it's because aircrafts are coming in to land into the airport. That's Class C. That's really the way that it looks. Again, what you're worrying about, you are worrying about the inner circle that goes from the surface to something. And that number is somewhat irrelevant because you know you're going to have to get approval because you know it's more than 400 feet. That's for sure. Put CVL in here because it's got C in it, as in the Class C airspace, but it's something completely different. The Mode C veil is something that we're going to find around Class B airspace. It refers to the instrument that manned aircraft need to have on board when they fly into Class Bravo airspace, and it's called a Mode C transponder. Now, the reason I mention this, it's not going to be on the exam, but some people look at the chart, and unfortunately, the Mode C veil, the color of it, is actually the same magenta color that the Class C airspace is. So some people look at it and say, why is there a big Class C airspace around a Class Bravo airspace? And what does that do? It's not really an airspace. It's not something that you have to worry about. So, and then I'll show you in a second, it has no effect on the UAS pilot, but this is what it looks like. This is a Class B for Phoenix. And if we look right here, do you see this big magenta circle around it? That's the Mode C veil. And see, it has the label right here. It says Mode C veil. Not something you have to worry about. It's just a ring that tells manned aircraft pilots that there is actually a requirement for special equipment. That requirement does not apply to you. You can just disregard, but I have to mention it because some students have been confused in the past, and I don't want you to be confused. So always going to be found around Class B airspace. Let's go ahead and take a look at Class C in SkyVector and in SketchUp like we did before for the Class Bravo airspace. This, the purple area right here, the magenta, it's called airspace. We have surface to 4,000 feet. This is all MSL, mean sea level. But because Fort Lauderdale is really close to the ground, it's like 65 feet elevation. We're just going to assume that MSL is the same as AGL in this case. And we have another airspace on the side here that goes from 1,200 to 4,000. You only have to worry about the airspace that's right here, from the surface to 4,000, because that's where you're going to be flying. Between surface and 400 feet AGL is where you have to worry about. This one, you don't have to because it starts at 1,200 feet. MSL, AGL, same number in this case. Then you don't have to worry about that. So you also notice that it abutes, it goes right against the Class Bravo airspace from Miami. It touches it right here, so that Class Charlie airspace would end right here with the Class Bravo airspace. Let's go up a little bit more. Further up, this one right here, this is West Palm Beach. West Palm Beach is also a Class Charlie airspace, and this one has a few more layers. You can see right here, there's this segment right here to right here to right here that goes from 1,600 feet to 4,000. Again, not something that we have to worry about because this airport is at 20 feet above sea level, so not too bad. Here's another layer, and it goes all the way around, this whole thing right here, except that little portion right here in the middle. This goes from 1,200 to 4,000. Again, we don't really have to worry about this one because we're not going to be flying in this with our drone. Now, we do have to worry about this one because it starts at the surface to 4,000 feet MSL, or 4,000 feet AGL for this specific airport. So here, we do have to worry about this segment. We're definitely going to need to get approval to fly in this airspace. The next one I want to show you is a little bit further to the west right here, just so you have an idea. This is a pretty standard. This is what